Retail investors are obsessing over silicon, bidding up AI chipmakers to historic multiples. But Wall Street understands a brutal reality. Chips are just the appetizer. Without unprecedented baseload power and industrial liquid cooling, those billion-dollar GPU clusters are nothing more than expensive paperweights. That exact bottleneck is triggering a massive reallocation of capital away from semiconductors and directly into the physical foundation. Today, we are tracking that money, breaking down the 5 critical layers of the 2026 AI infrastructure value chain to uncover the market's deepest economic moats. To track the institutional money, we must view the AI ecosystem as a closed-loop survival pipeline. It begins with primary power, where the massive nuclear and gas fleets of Vistra, Constellation, and the next-gen reactors of Oklo provide unblinking baseload generation. This raw energy enters the electrical grid, stepped down by Eaton and Schneider Electric, before passing through Vertiv's uninterruptible power systems to achieve absolute stability before hitting the servers. As the AI engine awakens, destructive heat forces Modine, nVent, and Vertiv to deploy liquid cooling solutions to keep the silicon alive. Simultaneously, the Optical Interconnects system, woven together by Amphenol's cabling, Arista's network architecture, and Celestica switches, ensures tens of thousands of chips communicate at the speed of light. The final destination is systems integration, where Dell, Supermicro, and HPE package these layers into turnkey supercomputers. The ultimate economic moat across this entire chain is extreme switching costs and massive, multi-year order backlogs. What is actually igniting this supercycle? Catalyst number 1 is a historic hyperscaler capital expenditure arms race, projected to exceed $650 billion. Crucially, capital allocation is shifting violently, with roughly 75% of that budget flowing directly into physical infrastructure buildouts. Catalyst number 2 is the energy bottleneck. An AI-powered search requires 10 times more power than a traditional search. This creates an exponential demand curve, forcing big tech to secure nuclear and small modular reactors as the ultimate solution. Power availability now dictates the absolute growth limit of AI. Catalyst number 3 is the thermal revolution. In 2024, traditional air cooling held a 78% market share, but rack densities exceeding 100 kilowatts have issued a death sentence to air cooling. By 2028, this dynamic flips entirely, with liquid cooling projected to capture 71% of the market. Having billions in capital is useless if your data center melts down. Let's dive into the foundational layer. Data center power demand is projected to surge 160% by 2030. The grid mix is pivoting to meet this, with natural gas at 40% and nuclear at 23% forming the critical baseload, supplemented by solar and wind. This asset-heavy model creates formidable 5 to 10-year barriers to entry. 3 titans dominate this arena. Constellation secures its nuclear dominance by restarting the 3 Mile Island facility to provide 835 megawatts exclusively for Microsoft, alongside a 1.1 gigawatt agreement with Meta. Vistra emerges as a hybrid powerhouse with 44,000 megawatts of total capacity, locking in a 1,200 megawatt behind-the-meter deal with Amazon. Meanwhile, Oklo, backed by Sam Altman, is pioneering 75 megawatt liquid metal small modular reactors, targeting a 1.2 gigawatt deployment from Meta. Hyperscalers are directly funding these assets to secure every available megawatt. The journey from the power grid to the GPU is a mission-critical pipeline. Stage 1 is the grid bottleneck. Wait times for high-voltage transformers have stretched to an agonizing 100 to 150 weeks, cementing Eaton as an irreplaceable powerhouse in electrical gear. Moving into facility integration, Schneider Electric rules the deployment of medium-voltage switchgears and modular microgrids, synchronizing massive power loads with IT monitoring. Finally, at the rack-level conditioning stage, where power draw exceeds 100,000 watts per rack, Vertiv acts as the final safeguard with millisecond precision uninterruptible power supplies. Preventing an AI training failure is paramount. Downtime costs millions per hour, meaning customers prioritize proven reliability resulting in massive switching costs and 3 to 5 year revenue visibility for these exact providers. Reaching the silicon level, traditional physics collapse. Next-generation Blackwell and Rubin chips generate brutal heat, exceeding 1,200 watts per chip. Traditional air cooling hits a hard ceiling at 20 kilowatts per rack. Trying to scale it results in a severely wasted physical footprint. The new mandate is the direct-to-chip revolution. Liquid coolants absorb and transfer heat 25 times more effectively than air, driving power usage effectiveness near a perfect 1.0. For 120 kilowatt architectures, this is strictly mandatory. Vertiv captures this surge as the dominant architect of coolant distribution units. Modine capitalizes by providing heavy-duty, outdoor water chilling systems for North American hyperscalers. And nVent delivers precision manifold systems with military-grade, leak-proof standards to ensure coolant safely reaches multi-billion-dollar server boards. 100,000 world-class chips become a depreciating liability if they suffer from GPU starvation. Massive clusters lose millions of dollars when chips sit idle waiting for slow data transfers. The physical barrier is the 2-meter copper limit, where traditional cabling suffers severe signal degradation. The 2026 architecture solves this through a hybrid symbiosis. Inside the rack, Amphenol's heavy-duty copper backplanes connect 72 GPUs with near-zero latency. But across the facility, 1.6T silicon photonics takes over, utilizing fiber optics to enable light-speed data transfers without degradation. High-speed Ethernet officially overtakes InfiniBand as the gold standard for backend networks, positioning Arista Networks as the supreme architect. Concurrently, Celestica steps in as the primary integrator for these next-generation 800G and 1.6T switch systems. The hundreds of billions spent across the supply chain ultimately converge at systems integration. The era of standalone servers is over. The total addressable market is surpassing $200 billion, fueled by an 80% CapEx shift toward fully integrated turnkey racks that mandate 100% direct liquid cooling. Dell Technologies leads the enterprise tier with a staggering $12 billion AI server backlog, leveraging a maintenance network spanning 180 countries and priority tier 1 NVIDIA allocations. HPE targets national projects as the sovereign AI veteran, boasting a $4.5 billion backlog backed by its Cray liquid cooling heritage and 60% water cooling efficiency. Supermicro commands the agile hyperscale segment, maintaining $8 to $10 billion in order visibility by producing 3,000 liquid-cooled racks per month with a rapid 2 to 4 week deployment. Execution risk here is terrifying. A single faulty cooling valve can destroy a $3 million rack. Customers pay for flawless integration, creating an ultimate ecosystem lock-in through proprietary management software. Synthesizing this multi-layered pipeline gives us the ultimate 2026 infrastructure watch list. From nuclear power titans like Vistra and Constellation, to the AI network brain of Arista, down to liquid cooling kings and precision manifold specialists. The sophisticated play is analyzing the valuation matrix, comparing the forward PE multiples against the 3-year EPS compound annual growth rates. Companies like Dell and Vistra present deep value with low multiples relative to aggressive growth. Conversely, cooling plays like Vertiv and Modine command premium valuations reflecting immense backlog visibility. We must also weigh the execution and macro risks, separating high-margin audit risk plays from highly stable grid infrastructure moats. The wealth generated in this supercycle will flow to those building the physical foundation of AI. Save this watch list, subscribe to the channel, and join us as we continue to dissect Wall Street's deepest economic moats.